Hello guys, today I want to talk about the continuous about the BGP configuration and show you how can we make a neighborship by BGP between loopback interfaces and how can we make a load balancing in BGP because by default BGP doesn't have any load balancing. Uh, Before we want to start I give some details. When we are looking at a loop back, let's go to paint. For example, here is the router in another AS and the other one. And then, sorry, my painting is not perfect. Uh, okay, and the second connection. And here we have the loop backs. Okay, when we have using the physical interface, everything is fine. When we set the configuration for BGP, uh, it works because from this interface to this interface, just we are using one TTL. Okay, but when we have a loop back, again we have another TTL also will extend. Sorry. Uh, and we need to go to second TTL. So here is one TTL, another one is the second TTL, and by default the BGP has just one TTL. This is the problem that happened, and I will show you. Then I show you how config and add some commands to extend the TTL for eBGP. This is the first matter. The second matter that I want to show you, here I connect two interfaces. If we go here and you will see we have two interfaces here. By default, we don't have any load balancing in eBGP. So there is some trick that I am using is that I make one, sorry, I make a one IGP here. In this IGP, so I set, set IGP here, and I add these interfaces and also this loopback inside here. When I add the IGP, the RIB, it will make it, and then in RIB we can see the route and they can pinging together. And after that I set this IGP, then I will go and config between these source of the loopbacks eBGP. When the eBGP wants to work, automatically look at the RIB and see these two interfaces, these two routes, and automatically without eBGP understand use the IGP to both of these interfaces like a load balancing. Okay, let's go to config and understand more about it. First of all, just fresh your mind. In R5, we have OSPF here and redistribute EIGRP. So if I go and make a show IP, IP protocol, I can see that we have here one. Okay, one BGP 65,500. This is that before config here, and now we want to make a neighborship with 64,000. And the other one is we had a OSPF one. It is inside my AS. I have these two here in R5. So because I have OSPF1, I want to configure OSPF2 between these two locations for make the IGP and add these interfaces and the loopbacks inside. The other thing that you must know is about the interfaces. Uh, these two interfaces is 10.10.1 gig 02 and gig 04 10.10.9.1, and the other side is 10.10.10.2 and 10.10.9.2 here the other side. The loopback is 5, so it is 551, it is loopback 1. The other side, we check it, show IP protocol. Now I am looking on R12. I have just a BGP 64,000, and if I check it, show run section router BGP, you will see we have just iBGP between these two routers. We don't have anything else. We don't have any neighborship between 64,000 and 65,500. So we have just iBGP between these two. And if you check, we have only 64,000. This is for inside iBGP. That's it. If I get show IP interface brief, we can again check it is 10.10.10.2, 10.10.10.9.2. These two interfaces. The other side I show you is 10.10.10.1 and 10.10.9.1. The loopback that it is router 12, I set this loopback 12.12.12.1. Okay, so let's go and start to config. So first of all, I want to make a OSPF. So I make a router OSPF, but we had one OSPF with number 1, so I choose 2. Then I will add the 10, 10, 10, 0, 0, 0, 0, 255 with wildcard, and make an area, for example, 10. I add 10, 10, 10, 9 also here, and 10, 9, sorry, 10, 9, oh, 9, 0. Then I add the loopback 5551 here. It is 0, 0, 0, 0, the wildcard. 0, 0, 0, area 10. Okay, we finish here this side. Now I am going in R12. I'm going in a router OSPF. I set any OSPF. I use it 1 because you know the process ID is not important. This side we don't have any router OSPF. I choose 1 no matter. The neighborship, you know, the process ID is not important. Just I make it. I don't want to make it same as here router OSPF2 that you see that process ID is not important and neighborship can happen. But that side we had OSPF1, so we cannot use same process ID. We need to use another process ID. Here I add 10, 10, 10, 0, 0, 0, 0, wildcard, and area 10. Now neighborship will happen. See, the first interface start make a relationship and neighborship 9 also I added, so the other one also now work, and the loopback that I need to add loopback is 12 12 12 1 12 12 12 1 area oh, I forgot to add the wildcard. Okay, our job done for OSPF. Everything finished and everything is configured, and now we have the relationship by IGP between these two networks. Just I give you more details. Um, I did it this configuration here. In fact, this kind of configuration mostly not happen between two AS. Maybe between the service providers because they trust each other. They agree to make a OSPF between them, not between the customer and service provider. This is not happening, and no, I think that no ISP accept to make a OSPF in middle with the BGP together, because easy can bring some route inside your router by bring it inside the OSPF, and this is hijack, and they don't allow to do by this kind of the configuration. But maybe between two ISP they trust each other and they agree to make a OSPF for the load balancing the traffic like this. So just pay attention. Here is laboratory. Just I make it between my organization and AS 64000. In real world, it's not like this. Okay, now we have IGP, so we will go to config BGP now. Six. I am going in router BGP. I am in R5, so 65,500. Okay, and now I say that uh, neighbor, the neighbor is 12, 12, 12, 1 with remote AS 64,000. Okay, I add this neighbor. I introduce this loopback. It's from 64,000 and vice versa. I will go in router BGP here 64,000 and says okay, we have a neighbor 551 with remote AS 65,500, and if we wait a long time nothing will happen. As I told you, now in BGP we introduce these sources 551 and here the neighbor 12.12.1. But now BGP, if we can by Wireshark, you can record the data. You will see send the TTL. TTL here will finish because TTL is 1. We need to do two configuration. First of all, we must introduce that this source is not a physical interface. So we need to make the update source and says that okay, this in this IP, this neighbor that I introduce you is belong to loopback one. Okay, this is a loopback from the my neighbor, and the number of the loopback you must have it. It is loopback 1, 2, 3, which one? And both sides we set it loopback 1. Here also we need to introduce our source that okay, I introduce it, but this loopback is belong to loopback 1, this IP, and now we update the source and introduce it, but the TTL is same as before and not changed. For extend our TTL, in fact, we have two solutions, but they have some different. If we go here and let me bring it here, show you. We have two commands that we can use. Disable connected check. It means one hop away eBGP peer using loopback address. I can use this command and in both sides, and or also I can use eBGP multi-hop. But there is a difference between them. For disable connected only make extend one TTL more. It means that when you have a eBGP between these two, you can use disable connected. For example, you think that between R5 and R11 you want make this eBGP. So now it is 1 TTL, 2, and for the source of loopback is 3. Disable connected, we cannot use disable connected. But eBGP multi-hop has the function that you can extend your hop maximum to 255. That's the matter that you must understand it. With eBGP multi-hop, you can extend the TTL 3, 4, 5 till 255. This is the matter that you must learn about it. So here I use and make it, okay, make it 2 TTL, and this side also I make it extend my eBGP multi-hop to 2. And now the membership of the eBGP must be happen, because now we extend the TTL, and yeah, you can see the eBGP neighborship happen. The other side also you can see it is off. I try to explain you very simple to understand it, how can we config, and I think it's very clear now, everything for you. Now I want to show you to check and understand it. If we get the show IP BGP in R5, we have another loopback also from the side in router 12. In router 12 we have 64, 64, 64. Here also I mentioned. Let's go and make a trace route to 64, 64, 64, 64 with source of loopback 1 in numeric. See, when I send the trace, it means that from router 5, trace this loopback 64, 64. It showed 10, 10, 10, 2. Next trace route, it shows 10, 10, 9, 2. Again, next trace route, it goes through 10, 10, 10, 2. You will see, I told you before that now use both of these interfaces for sending the traffic. This is the load balancing that now I made it by IGP in middle of the eBGP neighborship. I hope this video be useful for you. Please follow me, and if you have some comment, good, bad, no problem, please write it. I hope you enjoy and have a nice day.